January 1945. Southern Germany. The fastest piston-engine aircraft ever built roared through frozen skies. The WWII Do 335. Its pilot, a 1-year-old Luftwaffe flyer, with less than 50 hours of combat experience, dove hard toward the tree line, his only hope to shake the P-47 Thunderbolt locked onto his tail. His aircraft was faster, sleeker, revolutionary, but none of that mattered the moment he tried to roll right and the control stick refused to move. His arms tensed, veins bulged. Nothing. At over 450 miles per hour, the forces acting on the ailerons had turned his machine into a bullet, a straight-line missile he couldn't steer. The airframe was intact. The engine still screamed. But the machine was no longer his. It had become a coffin at speed. Behind him, the American Thunderbolt banked with ease, the pilot barely flexing his wrist as the aircraft rolled gracefully into position. At that velocity, the German pilot was paralyzed, fighting the laws of physics with human muscles. The American was dancing, aided by a control system his enemy didn't even know existed. The Do 335 pilot died seconds later. Not because he wasn't fast enough, but because he was too fast to survive. This is not a story about jets or rockets or secret weapons. This is a story about one overlooked truth that decided the fate of hundreds of men in the skies over Europe. A truth buried in the control stick and the flight surfaces and the very ability to turn. In the closing months of World War II, speed was no longer enough. Victory belonged to those who could still maneuver when others could only fall. This is the forgotten war of control. And it began where the air grew thin and the stick grew heavy. Speed was the obsession. As the Third Reich entered its final desperate phase, German aviation turned toward a singular solution: outrun the enemy. Outrun the numbers. Outrun defeat. The skies over Europe had become the final chessboard, and the Luftwaffe's engineers believed speed was their queen. If Allied fighters were faster, the Germans would build faster machines. If the enemy had numbers, the Germans would rely on velocity to strike, disengage, and survive. It was a seductive logic, and by late 1944, it became doctrine. The Messerschmitt Me 262, the first operational jet fighter, promised 540 miles per hour of blistering performance. The rocket-powered Me 163 was a meteor launched from a runway. And then came the WWII Do 335 File, a piston-engine marvel so fast it could outpace most jets in a dive. On paper, these aircraft looked unstoppable. In wind tunnels, they shattered records. But in the cockpit, in the flesh-and-bone reality of aerial combat, they carried within them a silent, growing flaw. They were machines designed for speed, not for control. The Germans built fighters that could fly faster than anything before. But they failed to ask a brutal question: could a man actually fly them? At high velocity, air resistance doesn't increase linearly. It rises exponentially. The faster you go, the more brutal the forces pushing against every surface of your aircraft. Control surfaces, the ailerons, elevators, and rudders become harder and harder to move as speed increases. Above 400 miles per hour, this isn't a minor issue. It becomes a wall. And the Luftwaffe hit it head first. Their best pilots suddenly found themselves strapped into fighters that could outpace the enemy but couldn't turn to face them. Mechanical control systems, the kind operated by pulleys, cables, and sheer pilot muscle, were never designed for these speeds. At 450 miles per hour, trying to move the ailerons on an FW-190 or BF-109 required over 60 pounds of lateral force. That's the equivalent of bench pressing a small child with one arm while hurtling through the sky in a vibrating, shuddering death machine. The problem wasn't theoretical. It was physical. German pilots quite literally couldn't move the stick enough to bankroll or evade. The Luftwaffe knew it. But they didn't know what to do about it. The cockpit of the BF-109, once the pride of German aerial supremacy, became a steel trap. Its narrow design meant that pilots were physically constrained, their elbows jammed against the sides, their leverage gone. The faster they dove to escape Allied pursuit, the more control they lost. Dive too deep, and your stick turned to stone. Roll too fast, and you couldn't recover. The fighter that was supposed to save you became a missile you couldn't steer. German engineers recognized the issue, but not at scale. They had tried solutions, Flettner tabs, aerodynamic assists, minor design tweaks, but none of it was enough. The Me-262, for all its revolutionary power, still suffered from heavy controls at speed. The Do-335, with its push-pull propeller system and unprecedented speed, was plagued by the same fatal flaw. These aircraft could outrun anything, but they couldn't outmaneuver their own physics. And the physics didn't care about ideology. They didn't care about desperation. They didn't care about Reich's survival. What was supposed to be a new era of German air superiority became a tragic farce. Aircraft were handed to young, barely trained pilots who couldn't physically control them in combat conditions. Reports came back of sticks locked in place of ailerons, refusing to respond, of crashes that weren't caused by bullets, but by the inability to turn. The Luftwaffe's own data showed it clearly. More pilots were dying not because they were outgunned, but because they couldn't steer. The Americans, meanwhile, had taken a different path. The P-47 Thunderbolt and P-51 Mustang weren't faster in a straight line than the Do-335. But they were flyable. At 400 miles per hour, the stick still moved. The aircraft still responded. That alone was decisive. In a dogfight, the ability to roll even a fraction of a second sooner meant the difference between life and death. While German pilots fought their own machines, Allied pilots fought the enemy. And that's where the real tragedy lies. German engineering brilliance was never in doubt. They built some of the most advanced machines the world had ever seen. But in their race for velocity, they lost sight of the pilot. They forgot that a fighter plane isn't a bullet, it's a blade. It needs to turn. It needs to be wielded. It needs a human hand, and that hand has limits. Muscle has limits. Tendons tear. Joints lock. Bones break. You cannot will your way through 70 pounds of resistance at 500 miles per hour. Not in the air, not in combat, not when your life depends on it. By designing aircraft that exceeded human capability, the Luftwaffe doomed its own men. These were not design flaws. They were design betrayals. And the worst part, they didn't see it until the bodies started falling from the sky. The control crisis wasn't just a problem. It was the fatal contradiction at the heart of late-war German aviation. Their aircraft were too good for their own pilots to fly. This wasn't just a matter of mechanics, it was philosophy. German design favored the machine. American design favored the pilot. One built aircraft that could dominate wind tunnels. The other built fighters that could survive the war. And survival in 1945 was the only metric that mattered. The Luftwaffe believed speed would save them, but it didn't. It couldn't. Because speed without control is a death sentence written in smoke and fire. And thousands of feet above the burning forests of Bavaria, young men in advanced aircraft found out too late that they were passengers in machines that had left them behind. While the Luftwaffe was engineering masterpieces that no man could fly at full speed, the Americans were quietly solving a different problem. Not how fast a plane could go, but how long a pilot could fight. How long he could stay in the turn. How many times he could roll, climb, dive, and recover without his arms giving out. It wasn't about brute force. It was about control. Consistent, responsive, human control even at the edge of the flight envelope. That's why when German pilots were muscling against immovable sticks, American pilots were flying with fingertips. From the beginning, American design philosophy took a different path. Engineers at Lockheed Republic North American and Bell didn't chase theoretical perfection. They chased survivability, maneuverability, pilot endurance. They understood something critical: the best aircraft in the world is worthless if the man inside it can't fly it under stress. Where the Germans believed technology should stretch human limits, the Americans believed technology should respect them. And so came the breakthrough. Not one miracle device, but a layered, practical approach to making fighters flyable at high speeds. Servo tabs, spring tabs, boosted controls. 3 answers to the same question. How do you keep control forces manageable when airflow wants to rip your control surfaces out of your hands? Let's start with the spring tab. the quiet hero of late-war aviation. This small, deceptively simple surface, attached to the main ailerons, elevators, or rudders, deflected in the opposite direction of pilot input. It used aerodynamic pressure against itself to help move the main surface. As speed increased and forces grew heavier, the spring compressed further, making the tab work harder, exactly when the pilot needed the most help. No electricity, no hydraulics, just physics leveraged. The British had perfected it with the Hawker Tempest. But the Americans weren't far behind. On the Republic P, 47 Thunderbolt engineers implemented aerodynamic assists and electric trim motors to keep control responsive. On the P-51 Mustang, North American Aviation balanced the control surfaces meticulously, not just for high-speed responsiveness, but to prevent fatigue during long-range escort missions. The aircraft flew like a dream at 400 miles per hour, not just because of its Merlin engine, but because the stick didn't fight the man holding it. And then there was the P-38, Lightning Lockheed's twin-engine, twin-boom monster that terrified the Axis. It had a problem early on: compressibility. In steep dives, the nose would lock and pilots couldn't pull out. But instead of ignoring the issue or pushing the aircraft past pilot tolerance, engineers, including a brilliant young technician named Ben Rich, helped redesign the elevator control system with boosted surfaces. By using hydraulic and mechanical assistance, they gave the pilot back his leverage. The Lightning went from dive trap to dogfight legend almost overnight. Meanwhile, Colonel Benjamin S. Kelsey, a visionary figure in U.S. Army Air Force's development, was fighting to push these ergonomic improvements into every design. He understood that combat wasn't just won with speed or firepower, but with consistency. If a pilot had to fight his own aircraft just to turn, he couldn't fight the enemy. And no matter how many horsepower you packed under the cowl, if the stick locked at 420 miles per hour, you might as well be flying a dart. American engineers built with that reality in mind. They tested with human pilots, pushed aircraft to the limit, and refined the controls for the man, not just the machine. This wasn't an accident. It was intention, philosophy, and teamwork between designers, test pilots, and combat veterans. A feedback loop the Germans never truly embraced. Where the Reich pursued the elegant, idealized supremacy of speed, American engineers made messy, practical choices. And they worked. The difference showed up in combat. In 1944, a Mustang pilot diving through cloud cover at 460 miles per hour could still nudge the stick and bank left. A Thunderbolt racing into a ground attack run could pull up in time without tearing its pilot's shoulder out of socket. These were not lucky moments. They were engineered outcomes. Thoughtful, tested, built-in survivability. While the Germans wondered why they were being outturned in vertical dives, American aircraft kept maneuvering, kept firing, kept returning home. The result was devastating. Luftwaffe pilots found themselves in aircraft that could no longer respond fast enough, while the Americans rolled, pulled, and adjusted like their fighters were running on silk. More than once, gun camera footage showed German aircraft plummeting in a straight line. No evasive maneuver, no banking, just a helpless dive. They weren't being stupid. They were being betrayed by their own control systems. Back in the design rooms at Lockheed and Republic, the engineers didn't celebrate. They just kept improving. They refined trim tabs to reduce control stick oscillation. They analyzed pilot reports line by line. They reinforced control columns where strain fractures appeared after too many 5 grams pullouts. It was iterative, focused engineering. Not for glory, for survival. And the best part, these systems were maintainable. The ground crews loved them. No hydraulic lines to rupture under stress. No complex machinery requiring factory calibration. Spring tabs could be adjusted with a wrench and a sharp eye. Boosted controls could be serviced in muddy field hangars. The systems were simple because they had to be. Simplicity was the American superweapon. The final irony was this. While Germany fielded futuristic aircraft that looked like something from science fiction: jets, rocket planes, hybrid push-pull monsters, they were undone by a humble truth: their pilots couldn't steer. And the Americans, with control tabs, boosted sticks, and aerodynamic empathy, turned every cockpit into a place where man and machine could still fight together at any speed. In war, there's no victory in flying the fastest if you can't bank when it matters. No triumph in designing the sleekest shape if the hands inside can't move it. What the Americans built was not just aircraft. They built trust between pilot and plane. And in the skies above Europe, that trust killed faster than speed ever could. All the engineering in the world couldn't help when the canopy filled with smoke and tracers screamed past the wingtips. That's when control, not theory, not blueprints, decided who lived and who died. And in the final months of World War II, the skies over Europe bore silent witness to a truth too brutal for German designers to admit. They had built war machines that their own pilots couldn't fly when it mattered most. December 1944, somewhere over the Ardennes, Lieutenant Karl Heinemann of Jagdgeschwader 11 rolled his FW-190 into a hard dive, trying to shake two P-51 Mustangs, closing fast behind him. He slammed the throttle forward engine, roaring past 450 miles per hour. For a moment he believed he had escaped, but when he tried to bank, left nothing. The stick felt like it was set in concrete. He pushed harder, shoulder-straining teeth gritted. Still, nothing. The Mustang behind him peeled effortlessly into position. A burst of .50 caliber fire shattered his left wing. Heinemann ejected seconds before the aircraft exploded into the forest below. He would later tell his debrief officer, "I wasn't shot down. I was locked out. My plane stopped listening." That story wasn't unique. All across the Western Front, in the winter of 1944-45, German pilots found themselves entering deadly spirals, not from enemy bullets, but from their own design decisions. The Luftwaffe had trained them well. Their instincts were sharp, their courage unquestioned. But instinct means nothing when your ailerons won't move. When your aircraft hits 400 miles per hour and the controls seize up like frozen metal. They tried everything: shallow dives, energy retention, even brutal shoulder dislocations, anything to regain control. It rarely worked. Hauptmann Ernst Kramer, a veteran with over 90 kills, described it like drowning in the sky. The faster I went, the less I could move. At 420 miles per hour, I was trapped in straight flight. No turns, no rolls. Just a dead man, waiting to be noticed. The Americans noticed. P-51 seconds and P-47 seconds, with their boosted and tab-assisted controls, thrived in those same conditions. They maneuvered at 420 miles per hour as if still in training mode. Mustangs dove, rolled, and snapped into attack angles with surgical precision even at breakneck speeds. Their pilots didn't have to wrestle their machines. They wore them. The control surfaces responded with smooth, fluid confidence. The results were devastating. Over Belgium in early January 1945, a squadron of Tempests and Mustangs engaged a group of Bf-109 seconds, attempting to intercept a bomber formation. The Germans had the altitude. They dove aggressively, the classic defensive tactic. But what should have been a vertical escape became an aerial execution. At 430 miles per hour, the 109 seconds couldn't turn, couldn't roll, couldn't even zigzag. The Tempest followed them down, calmly adjusting pitch and roll as needed, positioning behind their tails like it was target practice. 6 Bf-109 seconds were destroyed in under 90 seconds. None of the British or American fighters took a hit. Gun camera footage from these engagements told the same story again and again. German fighters in steep dives, flying dead straight, no defensive movement, no evasive attempts, not because the pilots froze, but because the aircraft had. These weren't dogfights. They were high-speed executions where the Luftwaffe's finest pilots were pinned inside aircraft that had abandoned them, and it broke them. Beyond the technical failure was the psychological collapse. Veteran pilots, once confident in their ability to outfly any enemy, now feared the very thing that was supposed to save them: speed. They no longer trusted their aircraft. Some refused to dive past 380 miles per hour, even when it meant staying in gun range longer. Others tried to compensate by muscling the stick with both arms, ignoring pain, dislocating shoulders. Some simply never returned. Their aircraft found buried nose first in the dirt with no bullet holes, just silence. In squadron briefings, younger pilots asked, Whispered questions. What do I do if the stick locks up? The answers weren't tactical. They were desperate. Hold your breath. Pray. Pull harder. That was all they had. The Luftwaffe's high command, still clinging to the myth of technological superiority, failed to act. Reports poured in from squadrons, from crash investigations, from captured airmen. They were filled with phrases like, control, froze, unresponsive at speed, impossible to maneuver. Still, production continued. Still no major redesigns. Germany was out of time, out of steel, and out of engineers. But the Allies were far from out of aircraft. The result was a complete breakdown of Luftwaffe tactics. High-speed dives, once a reliable escape from inferior Allied fighters, became suicidal. Outnumbered and outmatched German pilots tried to avoid combat altogether. The Tempest in particular became infamous for hunting down fleeing aircraft and catching them in dives they could not control. Squadron leader David Fairbanks of the RAF recalled, "We'd see them dive, and we'd smile, because we knew they were sealing their fate. They couldn't turn. But we still could. The American advantage in control responsiveness wasn't flashy. It didn't make the front pages like the Me-262, but it won the sky. Not because their planes were faster, not because their guns were bigger, but because at 420 miles per hour their pilots still had choices. The Germans had none. And when choice disappears, so does survival." What makes this tragedy so haunting is how silent it was. There were no fiery malfunctions, no sabotage designs, just the cold, steady crush of air against control surfaces, a force that grew stronger than human muscle, faster than cockpit reflexes. And in that space between the need to move and the inability to act, the Luftwaffe bled out. The war in the air was no longer about daring maneuvers or heroic gambits. It had become mechanical Darwinism. And the Luftwaffe's best pilots, trapped in beautifully engineered machines that ignored their commands, were hunted like prey in a sky that no longer belonged to them. By the time the Luftwaffe understood what was killing their pilots, it was already too late. The reports had been piling up since mid-1944. Pilots describing frozen controls during dives, fatal crashes with no combat damage, gun camera footage showing German fighters flying straight to their deaths, unable to evade. Engineers at Messerschmitt and Focke-Wulf saw the patterns. They examined wreckage. They watched the footage. They read the testimonies. And they finally understood it wasn't enemy bullets ending these missions. It was their own machines, their own assumptions, their own blind spots. But recognition did not equal resolution. The Luftwaffe's technical response came slowly, choked by bureaucracy, crippled by hubris, and ultimately rendered futile by a collapsing war effort. The engineers knew what was wrong, but the factories were bombed, the timelines unrealistic, the leadership obsessed with fantasy weapons that promised salvation through spectacle, not through survivability. While Allied engineers were refining spring tabs and control-boosting systems, German designers were chasing miracles. Jet propulsion, rocket-powered interceptors, radar-guided missiles. Their focus was on leapfrogging the present, rather than fixing the deadly flaws of the now. The Me-262 Schwalbe, for all its speed and innovation, still suffered from heavy controls at high velocity. The Me-163 Comet could reach incredible altitudes, but its pilot couldn't maneuver precisely enough to engage in a dogfight. The V-2 rocket soared into headlines, but it couldn't win air superiority. And none of them could save a fighter pilot trying to roll at 420 miles per hour with a control stick that felt welded to the frame. This was the fatal error. German engineering became intoxicated by complexity. There was a belief, almost religious, that the solution to any problem lay in designing something more advanced, more ambitious, more revolutionary. Simplicity was seen as primitive. Basic fixes were beneath attention. The result? Dozens of miracle weapons, but no solution for a control surface that couldn't be moved by human hands in combat. Meanwhile, the Americans were building aircraft designed for war, not parades. Their goal wasn't to impress Berlin or win design awards. It was to get a pilot home. Every bolt, every control tab, every inch of cable was optimized not for theory, but for combat. For stress, for sweat, for fatigue. Their aircraft were born from mud and oil and wind tunnels, not marble halls and propaganda films. The cultural divide was as clear as it was fatal. In Germany, engineering was seen as an art form, a means of demonstrating intellectual superiority. In America, engineering was problem-solving, plain and simple. The Germans pursued machines that pushed the boundaries of what was possible. The Americans pursued machines that worked. That's why when German engineers finally proposed fitting spring tabs to their aircraft in late 1944, the suggestion was dismissed or delayed. Implementing the fix would have required extensive redesigns of control systems, retraining of crews, new parts, new testing, and most importantly, time. And by that point, time was something the Third Reich no longer had. Factory output was crumbling under relentless Allied bombing. Skilled workers had been conscripted or killed. Material shortages meant that even maintaining existing designs was a logistical nightmare. Prototypes were developed, a few modified FW-192s with hydraulic boost, some test beds with servo-assisted ailerons, but they never reached mass production. The war would end before they ever took to the skies, in meaningful numbers, and the pilots kept dying. The tragedy deepened, because the solution had been within reach the entire time. The spring tab, an elegant, low-tech fix, could have been implemented far earlier. The British had been experimenting with it since 1942. Hawker and the Royal Aircraft Establishment had gone through dozens of iterations before integrating it into the Tempest. The Americans adopted similar principles across multiple airframes. But in Germany, the idea was overlooked, ignored, dismissed as unnecessary or too simplistic to matter. It wasn't a lack of intelligence. German engineers were some of the most brilliant minds of their era. It was a failure of humility. They couldn't believe that something so basic could solve a problem that seemed so large. They were looking for genius and missed the wisdom of functionality. And so the Luftwaffe entered 1945 with a fleet of technologically advanced, aerodynamically refined, utterly doomed aircraft, planes that looked perfect on paper but betrayed their pilots at altitude, planes that wowed visiting generals but couldn't bank under pressure, planes that were born in the minds of visionaries and buried in the fields of Belgium and France. The story of those final months isn't just one of material collapse or fuel shortages. It's the story of engineering philosophy turned fatal, a culture that celebrated brilliance but forgot to ask, can a man fly this under fire? A system that prized the radical over the reliable, the spectacular over the survivable. And that's why Germany lost the air war, not because they didn't build fast planes, but because they built unforgiving ones. The Americans didn't win with the prettiest aircraft. They didn't need miracle weapons. They won because their designers understood a truth, that every pilot would learn in blood, no matter how fast your engine, how powerful your guns, or how sleek your design. If you can't turn, you're dead. That was the unforgivable sin of the Luftwaffe's final designs. And by the time they recognized it, the sky had already moved on without them. Germany lost the skies, not for lack of invention, but because it forgot the pilot. And when the war ended, the world remembered. The lessons written in wreckage and gun camera footage didn't fade with the smoke. They were studied, dissected, rebuilt, and quietly woven into the future of flight. The tragedy of unresponsive control systems at high speed became more than a cautionary tale. It became the foundation for a new era of aviation. Engineers on every side, Allied, Soviet, even German survivors had seen what happened when aircraft outgrew their pilots. They'd seen brilliance turn to betrayal at 400 miles per hour. And so, in the years after 1945, they set out to ensure that no pilot, civilian or military, would ever again be trapped behind a control stick that refused to move. One of the first places this transformation took root was in American civilian aviation. As commercial airliners grew larger and faster, the need for smooth, consistent control became paramount. The spring tab system, once a fighter pilot's secret weapon, found new life in designs like the Douglas DC-6. Its control surfaces were aided by aerodynamic tabs that made long-range flights manageable even in rough weather. The principle was simple but revolutionary. Let the aircraft work with the pilot, not against him. Then came the Boeing 707, a symbol of modern aviation. Flying near transonic speeds, the jetliner relied on boosted control systems and refined force feedback mechanisms that owed their roots to the very solutions American engineers had tested in P-47 seconds and P-38 seconds. Pilots could bank a 707 at 600 miles per hour with precision and ease, not because the plane was perfect, but because its controls had been shaped by wartime pain. And the world watched. The Soviet Union, eager to match American performance in the air, studied every captured aircraft and engineering note they could get. They examined Tempests, Mustangs, Thunderbolts. What they saw wasn't just superior engines, it was superior ergonomics, control feel, maneuverability under pressure. This led directly to a revolution in their own fighter designs. The MiG-15 was fast, but it still suffered from high-speed stiffness. But with the MiG-17, and later the MiG-21, Soviet engineers implemented control assistance systems that allowed pilots to maintain responsiveness well into supersonic flight. Their fighters didn't just chase speed, they chased control. The echoes of this transformation rippled forward through decades of design. Every cockpit that came after carried the fingerprints of 1945's lessons. Airbus flight control systems built on fly-by-wire technology offered layers of artificial feel designed to mimic the kind of feedback spring tabs once provided mechanically. Boeing continued to evolve tactile response systems in aircraft like the 757 and 777, creating a bond between machine and human that was as much psychological as it was physical. Because by then the lesson had sunk. Deep flight isn't just thrust and lift, it's trust. And that trust is built in the feel of the stick, in the pressure of the rudder, in the certainty that when you move, the machine moves with you. Not half a second later, not under protest, but instantly, intuitively. Like it wants to survive too. That was the legacy of those final battles in the skies over Europe. A legacy written not in victory parades or jet engine stats, but in control harmony, the silent partnership between pilot and plane. And it wasn't just about safety, it was about design philosophy. The Americans had shown that simplicity, reliability, and human-centered thinking could win wars. The Germans had shown that brilliance, when divorced from usability, could kill more of your own than the enemy ever would. One philosophy built machines that outlasted their era. The other built machines that became museum pieces haunting beautiful and fundamentally flawed. That divide would go on to shape how the post-war world approached innovation across every domain. Western designers increasingly asked, how does this serve the operator? Soviet engineers blended complexity with ruggedness, knowing that over-engineering without pilot intuition could cripple performance. Even the reconstituted German aviation industry, when it rose again decades later, embraced a new pragmatism, one shaped by hard memory. The spring tab, once just a clever workaround for aileron stiffness, became symbolic of something far bigger. The difference between controlling power and being crushed by it. And this truth transcended aircraft. Because war had revealed that the ultimate battlefield wasn't just in the sky, it was inside the cockpit. Between hand and machine. Between decision and response. That split second where you pull and something pulls with you, or doesn't, and that's when you live, or don't. So the next time a pilot banks a 737 through turbulence with a smooth, confident roll, or a fighter jet twists into a supersonic turn without tearing the pilot's arms from their sockets, or a trainee lands safely on their first solo flight and says, "It felt like the plane was helping me," know this. They are flying with ghosts. Ghosts of men who died in machines that couldn't turn. Ghosts of engineers who chose simplicity over spectacle. Ghosts of hands that once pushed against a frozen stick and never pushed again. That's the real legacy of the light touch. Not a tab, not a cable, but a philosophy, born in fire and crash and silence. A reminder that technology must amplify humanity, not abandon it. That every cockpit is a covenant between flesh and steel, between thought and action. And that covenant was signed irrevocably over the burning forests of 1945 when a few aircraft learned to turn and the rest were lost to the straight lines of history. In the end, the war in the skies wasn't decided by who flew fastest, who had more firepower, or whose aircraft looked the most advanced. It was decided by who could still turn when it mattered, who could pull the stick and feel the aircraft respond, who had a machine that worked with the body, not against it. The Luftwaffe, for all its innovation and engineering brilliance, lost sight of this. Their pilots were betrayed not by cowardice or inferior skill, but by a fatal disconnect between design and reality. They flew machines that dazzled on the drafting table but failed at 400 miles per hour. The Allies, especially American and British engineers, chose another path, one of practical solutions, human-centered thinking, and relentless refinement. A small, almost invisible device like the spring tab became the quiet hero of aerial warfare, not because it was glamorous, but because it worked. Because it listened when a pilot cried out with his hands, "I need this plane to move." From that truth came a new standard. Post-war aviation, both civilian and military, absorbed the lesson deeply that speed and power mean nothing without control. And control means nothing without trust. Every airliner banking over a city, every fighter slicing through the sky, every instructor guiding a trainee, they all owe something to the pilots, who once couldn't turn, and to the engineers, who decided that would never happen again. This wasn't just a technical fix. It was a cultural awakening. A shift from building weapons to building relationships between man and machine, between decision and response, between life and the split-second margin that defines it. That is the legacy of the light touch, and it will fly with us forever.